you and I actually collaborated behind the scenes on a blog. And the blog was talking about peak performance versus real world performance. I used the Bugatti Veyron as an example. Right? It was the fastest car in the world at the time. It could do 407 kilometers an hour, I think it was. So 250 miles an hour, whatever that converts to. And yeah, it's the fastest in a straight line. It's the fastest top speed. Fantastic. But how sustainable is that in the real world? And there was two constraints. One of them was its fuel tank, and one of them was its tires. So its fuel would run out in 12 minutes at that speed. So it wasn't sustainable for a period of time. You had to be on one of those big, oval tracks, and it would run out of fuel very, very quickly. Luckily, though, it ran out of fuel before the tires exploded from the heat, because that was the second constraint, which was the tires would only last 15 minutes at that speed due to heat and the expansion and the G-force and the pressure. So then you compare the Bugatti Veyron to a very typical car that any of us can afford, and it's going to be probably more reliable and day to day give you the exact same outcome at 1/100th of the price. So that blog was called Peak Performance versus Real World. And I think to your point, if you compare a product, and let's say product A has 10 million IOPS of capability read and 10 million write, and then another one has 2 million read and 5 million write. I'm just making up numbers here. If your requirement is only 1 million, it doesn't matter that one of them is 10 times faster. Right? It also doesn't matter if you eliminate the I/O having to occur in the first place. So this movement we talked about, if we eliminate that movement of data, then that requirement for back-end performance is lower, and you can buy a lower performance device by just simply being intelligent, which was the VAAI you talked about earlier. But you've got a key point here, I can tell.
So it's funny, right? I don't remember if I did this publicly, if I did it privately. But years ago, I have you ever looked at what Red Bull F1 Racing, where they've taken the cars and they've put them in non-racing environments to see how they perform? So they drop them in the desert and they run them on sand, they drop them on ice and they see how they run, right? And I'm like, this is really analogous to like what we do. Like you could be super fast, but the environment doesn't allow you to capitalize on what that car can deliver, because the car wasn't designed for that. And moving data, if your company's looking at an AI initiative right now and looking at it as a silo, I get it, but you're going to store multiple copies of your data. You're going to end up taking more rack space and power, and then you'll never get to the efficiency that you want because of the data shuffling. And so going back to that conversation we had where they were like, well, hey, this other vendor writes at a more equal read and write level. It's like, by and large, almost absolute, but by and large, AI is about taking a large volume of data, processing it, and giving a refined output. It's not the other way around. So it is read-centric, and it's random read-centric in terms of that space. The reason this customer was worried about reads and writes is because they had to load that data all the time. So they were like, I don't know if you can write data fast enough as it comes off of the legacy NAS. And it's like, we write data faster than the legacy NAS can read and send us the data, right? So, but again, they're trying to solve a time issue, because what they would not do is replace the legacy infrastructure with parallel file system because of the rigidity and the client, impacts of having to maintain it that we kind of talked about earlier when we were talking about HPC. And so, if I just pause here, right? February 2006 was when VMware released vSphere 3. That was the moment where adoption for VMware took off. And every enterprise wanted the value of consolidating, at that time, tier 2 and tier 3 applications, right? It wasn't about performance. It was all about, I've got a data center full of underutilized hardware assets. And I remember that, right? So you had the leadership had FOMO. We have to adopt this technology. We've got to move forward. And you talk with infrastructure people, and this conversation probably lasted about 4 years, from like 06 to 10. the infrastructure folks had no idea what to do, what to purchase, or what to buy. The default behavior for most, go buy a SAN. And then what did you run into? You ran into a clustered file system that couldn't scale. You had SCSI locking and other scale issues. The number of runs you could make or volumes from a SAN, right? Didn't work. And then when you ran into performance issues, customers were doing things like concatenating volumes together and putting the clustered file system on top. And we were at NetApp and we're like, there's a faster way to do this. Get rid of the clustered file system. Just do, at that time, the best NFS platform in the world, the NetApp NFS platform. And then because we did direct storage to the hypervisor, then the next thing we did was let's start doing API calls directly at the virtual machine or virtual disk level down to the storage level. So we could do snapshots and clones and start to provide data services directly to the VMware admin. And then, right, these, large SAN and NAS platforms had all this redundant data. So, you roll out data reduction and you change the economics of the environment. And then the backup environment changes, right? There was no Veeam or Cohesity or Rubrik in 2000. Well, Veeam maybe in 2006, they saw it coming. But, right, like you had to get granular on your level of backup. Same thing on networking. Software-defined networking came out because you wanted to be able to tweak the networking all the way down to the virtual machine, not just the endpoint. From that, right, your monitoring tools got granular. And I think I share this with you is because I think we're in that storm right now. The very beginning of this, is your infrastructure AI capable? And how do you want to adopt AI or accelerated computing? Because I don't believe it's its own thing. I don't believe you say, well, that's my silo for a large language model, and we're going to do some training and inference on it. I think AI and GPUs or IPUs, TPUs, whatever the platform is, I think it's pervasive. And I think it's going to be behind every type of analytical system that's within a customer's infrastructure. And so I don't think it's if this is coming. And I don't think it's, can I go afford to build another silo? I think you have to literally sit there and say, all right, what's my journey to adopt faster computing and having the benefits of my business of this acceleration, and what changes do I have to make in my infrastructure? And that set of questions and the whole, I don't know what to do from an infrastructure perspective, I think that's very relevant today because we meet customers every day who basically say, I don't know what I need. The AI initiative is coming from the board or the executive team down. It's got a lot of visibility. We've got big plans. And you can't fault me if I bought the fastest storage on the planet to support it because I don't know what it needs. And that's kind of where we come in and say, well, let's talk about what you're actually trying to accomplish, right? And going back to the example we had a minute ago about moving data, there's much more, right? About enriching data and what are your sources of data and how's it coming in? And do you need to pre-process the data? And, et cetera, yada, yada. But we've talked a lot and never even gotten to VAST yet.
Yeah, I think conceptually, though, we've covered a lot of really very important topics. And like you say, it was server virtualization, then it was HCI, then it was NetApp with NFS, then it was the flash storage arrays being more commercially attractive, all this kind of stuff. It's the same concepts. And obviously we're talking architecture on this podcast. This is why I always highlight to people, understand the concept first. Don't go down and design at the physical layer and talk to me about your storage or whatever if you don't understand what the business problem is and conceptually what you're trying to achieve, so that you can translate that into a technical solution and then measure it back to the business. So conceptual, logical, physical is what everyone should be, designing to. So anytime we have a problem, and you've pretty much followed this process in this conversation, by the way, you've talked a lot conceptually about what the problems are, and then you've translated that down the logical and physical layers. So very important for us to do that.